Our next plot that we're going to learn how to sketch is called a box plot. Before we learn how to do that, we're going to learn how to find the values that we need to create our box plot. The first values we need are called the quartiles. What a quartile does is it divides a data set into 4 equal groups. So there's the same amount of data in each set, not necessarily the same range of data. So it's really important to understand that. The quartiles divide the data set into 4 equal groups with the same number of data values, but not necessarily the same range of data values. And I will revisit that concept because it's very important as we're working through our examples. The steps for finding the quartiles are: first, you find the median. Of course, the data needs to be in order least to greatest to find the median. That cuts the data set in half. You have the lower half of the data and the upper half. And then you find the median again for each half the data, and that will divide it into 4. The lower median is called quartile 1. The median can also be called quartile 2, but typically it's just referred to as the median. And then the median of the upper half of the data is called quartile 3. We can find the range of the data overall, and we can compare that to the inner quartile range. The inner quartile range is the third quartile minus the first quartile, and that gives you the spread of the middle part of the data. If the middle part of the data has a smaller spread than the entire data set, that could mean you have an outlier. It could also just mean that the middle part of the data is clustered a little bit closer together and the data on the ends is spread out a little bit further. Finally, we have a 5-number summary. These are the 5 values that we put on our graph when we're creating a box plot. There's the minimum, the 3 quartiles, and the maximum data value. Today we're just going to practice finding that 5-number summary, so we'll start by finding the quartiles. The data for example 1 is how long songs are in seconds, and I have the data organized for you least to greatest so that we can save a little bit of time. Finding the median, it's the number in the center of the data set. We have 10 data values, so our median will be between 221 and 227. Our median will be 224. When you have 2 data values that are in the center, you add them together and divide by 2 to get your median. This cut the data set into 2 equal groups. Notice how we have 5 data values below the median and 5 data values above the median. Now that we have an odd number of data values, we have 1 that's exactly in the center. This is our quartile 1. And same for quartile 3. We have 1 data value right in the center. That's our quartile 3. The 5-number summary for this data set is the smallest data value, quartile 1, the median, quartile 3, and the largest data value. Finally, we're going to compare the range with the inner quartile range. The range is the highest data value overall minus the lowest data value overall. So 438 minus 129 gives us the range of the entire data set. We have a range of 309 seconds. The inner quartile range is the third quartile minus the first quartile. In our case, 344 minus 171, or 173 seconds for our inner quartile range. To compare these, the range should be about twice as big as the inner quartile range because it's covering twice as much data. The inner quartile range is only covering the middle half the data. If we double 173, which is our inner quartile range, we get a value of 346. That's bigger than the range overall. This says to me we have no outliers. If we did, the range would be bigger than it is. And it also tells me that the middle half of the data is actually more spread out than the data overall. Let's go back and take a look at our actual data values and see what I mean by that. First of all, as a reminder, if you don't count the quartiles, you will see 25% of the data below quartile 1, 25% of the data between quartile 1 and the median, 25% of the data between the median and quartile 3, and 25% of the data above quartile 3. So again, notice how we have the exact same amount of data values in each group, but not necessarily the same range of data. And we saw that with the interquartile range and the range overall. They didn't compare to one another the way that they should have if the quartiles went grouping numerically versus amount of data values.